Hey guys, it's Dr. Conklin. I'm here to do a review with you on congruent triangles and transformations. So, if we look at number 1, we're told a couple things. AC bisects this angle. A bisector cuts an angle in half, meaning the two angles are congruent, but it's also bisecting BAD and BCD. So we have these angles also congruent. And then if you guys remember, we have AC, which is the reflexive property shared by everyone, or shared by both triangles, not everyone. So we have an angle, an S, a side, and an angle. So there, if we look through our choices here, this is only for right triangles. This has no angles. Haha. This only has one angle. Okay? Let's look at number 2, guys. Which of the following, or for the given diagram, which of the following is true? So again, if we look at this, do you guys see how these are all angle, side, angle? Okay, so they're sort of asking us to go through and make sure our statements are the same. And if you notice here, these triangles are different. You see how they change them? So let's just write our own congruent statement. I'm going to do A, B, C. So let's do the same thing this way. A, D, C. Okay, so which one of those is the same? Yep, it looks like choice C, guys, is the only one that works. Okay, same idea on this one, guys. We're told that TV and RC bisect each other, which means that we're going to have two pairs of congruent sides. And then if you remember, this is a bow tie, so we have vertical angles. So this would actually be just for a little review, side angle side, since we are reviewing. I'm going to go from T to E to R, so T to E to R. So just be careful, guys. If you notice, I first went down this side, which means I want to start, sorry, I'm just going to keep changing the colors. I want to start so that I'm going from the outside in to where we just have the one little hashtag, and then out to where we have two. So that's going to mean that T is going to match with V. E is going to match well with E, right? And then R is going to match with C. So VEC. Now just a hint, guys, we could have also, no, actually that's the only way we could write it. So no, that's good. Okay, another one for congruent triangles. We're told AB angle ACB at the top is a vertex angle. So this guy up here. We have CM is perpendicular to AB. So we know that perpendicular lines, remember the upside down, give us 90-degree angles. And you really only need to put one of these symbols here, but I'm going to just put a little note here to remind myself, 1 and 2. So we have an angle, okay? And M is the midpoint of AB. If M is the midpoint, these two sides are congruent, okay? Which statement cannot be used to justify? So remember that not is sneaky. If you look at this picture, there's one more side that's congruent. Ooh, that was not a good drawing. Right here, A to C. That's another side. So if I look here and I sort of travel around the triangle, I have a side, my right angle, and a side. Okay? So which cannot be used to justify these triangles are congruent? Oh, and you know what, guys? We also were told it's isosceles, which means these sides are congruent. Oh my goodness, this is like everything. And actually, guys, I should have just taken a second to look at my multiple choice. What's the only way we can't use to show triangles are congruent, right? So this is bad. Remember, you don't want to swear at us. Please don't swear, either forwards or backwards. These are also all bad, okay? All right, now we haven't talked about this one in a while, but the rotational symmetry of a regular nonagon. A nonagon is a 9-sided figure. And the word regular means all the angles and sides are congruent. So I'm not sure if I'm going to be able to draw a nonagon in here, but let me just draw a triangle to remind you guys. When we're finding rotational symmetry, let's just review. If I draw a circle around this, what we're sort of asking you guys to do is say to yourself, hey, how many degrees do I need to go to get the same shape back? So hold on, I just want to put another color up here. So if you guys see, we have, I'm making like a little pendant. So if I rotate this around, do you see how it comes back to be the same shape? And we can actually do that 3 times because we have 3 sides. So to do it for a triangle, our rotational symmetry would be 360, because that's how many degrees are in a circle, divided by 3 would be 120. So for a nonagon, we're going to do the same idea. 360 divided by 9 would be 40. Okay, let's look at our next page. We're going to transition here into transformations. Which of the following statements would result in a figure ABCD being in quadrant 2? So I wasn't sure if you guys remembered what quadrants are, so let me put this in 1, 2, 3, and 4. Okay, we want to end up in quadrant 2. Here's quadrant 2. So here's the axis we could flip over. That would get us there. If we rotate it 90 degrees about point B, here's point B, 90-degree rotation, that would actually put some of the triangle in here, but not the whole thing. Okay, if we translate it down 4 to the right, wait, 4, oops, sorry, other way. Like if I try to move A, 1, 2, 3, 4. Do you guys see how that's not going to move it all the way over? Close. Now, if we flip out the y-axis, that is going to be the answer, guys. Oops, I circled that one. Because if I flip over here, like B is right here, B is going to move right here. And C would move and A and D. If I flipped over the x-axis, though, my friends, that would move to quadrant 4. So our answer is going to be choice 2. All right, number 7. Triangle XYZ is reflected about the vertical line x equals 3. What are the coordinates for Z? So this is a little bit of a review question. Here's Z. I'm going to count 1, 2, 3, 4, 5, which means I have to count the other way. 1, 2, 3, 4, 5. So we're a little bit off the grid. That's okay, we can still use this. So 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 8 here, and we're going up 2. So 8, 2 is our answer. Question 8. If the triangle were reflected across the x-axis, so let me just highlight that, and then translated 4 units to the left. So let me just review with you guys how to write that. Reflected over the x-axis, translated to the left. If you're translating to the left, you're only changing the x value, so that would be -4. And then we can't go anywhere else, so we're not going up or down, that's going to be 0. So let's move sort of 1 point at a time. If I'm reflecting over the x-axis, I'm going to count 1, 2, 3, 4. Oh wait, hold on, I didn't read all the question. This is why you guys got to read the question, my friends. Point B is up here, my loves. So let me just do point B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here's B prime after our reflection. Now I need to translate it to the left 4. 1, 2, 3, 4. So that's B double prime. So that's going to be, I think that's -10. 1, 2, -10, 6. Choice A. Okay, last one, my friends. And just a heads up, I would expect one like this on the exam, guys, but maybe we ask you to do every vertice in a triangle, which I don't think would be too much of a stretch if you can do one. All right, so if we look at this, we have 2 shapes, shape A and shape B. What is a transformation that maps A to B? So this one here, it's pretty straightforward, right? If you look at some of the points, this point here, this is 2 away, these are 3 away. All we're doing here is reflecting over the y-axis, Okay? And then the real thing we wanted to review, more than anything, guys, is, so this is A. Is this transformation a rigid motion? Yes. Why? The size and shape are preserved. Okay? So just a reminder, if we did something with a dilation, so say I had a triangle and I dilate it, is that a rigid motion? Right? Not a rigid motion when we change the size. Okay, please reach out if we can help in any way. And I'm sure you guys are going to do great on your midterm. Make sure you do these questions, and we'll see you later. Bye.